In 2027, NASA's Nancy Grace Roman Space Infrared Telescope is expected to launch and answer some of the questions astrophysicists have been debating for years finally. It may, if promises are kept, usher in a wave of self-discovery. A new era in astronomy. It will record the flickers you see in the sky when you look up at the night sky. Why are scientists doing this? Do they know something we don't? For starters, more powerful than the 2.0 current infrared space telescope James Webb, thousands of exoplanets are expected to be discovered. There is a sense of urgency this time. More than Webb and I wonder what is the rush to hunt for a new Earth. It seems the real priority is hunting for something in the Milky Way galaxy. I'll explain. NASA scientists, project managers, consultants, and contractors have been diligently studying every detail of the Roman telescope's to-do list in order to prioritize and choose its first mission task. Why did the team sweat these details while still in the production phase? Just ask Dr. Kristen McQuinn, who heads up the project. She says the mission holds the promise of transformational astrophysics. This answer could shape the future of cosmic discovery, I'm told. I thought Webb was doing a great job, but it turns out these telescopes on steroids don't live very long in prime condition. According to NASA, it will be the opening act to a $1 billion 5-year prime mission. And, I am happy to report, a decision has been made. When Roman launches, it will head straight to our Milky Way galaxy in order to map every little twinkle. One way it will do this is by microlensing. Listen closely, guys, for this wacky phenomena. As the telescope maps the Milky Way's center, they will use the microlensing process. That's when a star or planet closely aligns with an unrelated star in the background. Here's the coolest part. Mass, as you may know, warps the fabric of space-time because the universe is constantly expanding. So light from any distant star will bend around the closest object as it passes, acting as a sort of a magnifying glass. The increased brightness from the lined-up background star clues in the astronomer that there's an intervening object there, even if they can't see it. Then they can map it. Roman Telescope, NASA's next flagship observatory, is equipped with a powerful wide-field instrument. Here's what it looks like from inside the NASA Goddard Clean Room in Maryland. Roman's integrated payload assembly appears to be floating as a crane lifts it onto the spacecraft bus, surrounded by yellow scaffolding. Beside mapping the Milky Way galaxy in our solar system, the telescope's core mission will be to determine why the universe is expanding, and also to discover more planets capable of sustaining intelligent life. It will also examine dark energy, black holes, and space weather. This is a non-proprietary mission, as up to 700 hours are reserved for community-defined astrophysics. That's some nice outreach. However, what are we looking for in the Milky Way that we need to map it? What's up there? Resources? Aliens? But the survey never answered that, so I guess we'll wait and see. Back to the decision-making process of Roman's tasks. Examining protocol at this level is interesting. NASA formed a special committee to determine how to best use the time in space. The committee recommended early survey concepts that would benefit from advanced planning and maximize Roman's capabilities. Then, they combed through the results. So, their number one recommendation is what they call a groundbreaking survey of the galactic plane, the densely packed heart of our Milky Way. With Roman's unprecedented infrared clarity, scientists can map stars, dust, and stellar movements in ways never seen before. Other top themes included ultra-deep field imaging and GRISM spectroscopy to study the earliest galaxies and black hole growth, time domain surveys to capture supernova, exoplanet transits, and even population 3 stars. Another was solar system mapping to discover faint distant objects that could rewrite theories of planetary formation. It's cliché, but this really sounds like sci-fi stuff. Maybe the Jetson era? Let me know in the comments. Now that your astrophysics knowledge is up to speed, let's look into something we could all use more of, especially me: planning. According to its white paper on the subject, NASA's Roman team needed to nail down the telescope's agenda several years early for the best results. When dealing with such an expensive and huge project like this, pre-planning engenders collaboration, better software development, and synergy with ground-based observatories, according to the Roman group. It also ensures that the data collected is accessible, equitable, and transfers over expansive fields of science and research. Many people will have access to this instrument that even surpasses the Webb Telescope in its technological capabilities. The Roman telescope will, without a doubt, change how we see the universe and ourselves. But it all begins with an insatiable curiosity to answer those existential and scientific questions. NASA is betting that Roman finds these answers and more. It's a great time to be alive, so don't forget to look up and appreciate all the wonders that are yet to come.